this video, we are going to cover section 3.3, CPCTC, and circles. After studying this section, you'll be able to apply the principle of CPCTC and recognize some basic properties of circles. First, looking at CPCTC, suppose that in the figure to the right, triangle ABC is congruent to triangle DEF. Based on my congruence statement, I know which angles and which sides are congruent. So angle A would be congruent to angle D, angle B would be congruent to angle E, and angle C is congruent to angle F. I know side AB is congruent to side DE, side EF is congruent to side BC, and side AC is congruent to side DF. Now, in the portions of the book that follow, we'll often draw such a conclusion after knowing that our triangles are congruent. We shall use CPCTC as the reason. So CPCTC is short for corresponding parts of congruent triangles are congruent. By corresponding parts, we mean the matching angles and sides of the respective triangles. So we will prove triangles congruent, then in order to prove the sides or the angles congruent to one another, we will use CPCTC. Now looking at circles, my figure to the right, I have a circle. We name circles by their centers, so this circle would be called circle O. I can use this symbol here, a circle with a dot in the middle, to represent circle. Then the letter afterwards would be the center of that circle. Now another key piece of information is every point that is on the circle is the same exact distance from the center. So the points that make up the circle we call the rim, which is just the circle itself. Every point that is made up of this circle is the exact same distance from the center. Now looking at circle P, I have points A, B, and C that lie on circle P. They lie on the rim. PA would be called a radius. PA, PB, and PC are called radii. All radii of a circle are congruent. This is a very helpful theorem that we'll use when trying to prove triangles congruent that are either contained inside or outside of a circle. Now looking at area and circumference formulas, from previous math courses you may remember formulas for the area and circumference of a circle. Area of a circle is pi r squared, and circumference of a circle is 2 pi r. Remember, area of a circle refers to the size of the shape, where circumference of a circle refers to the distance around the rim of the circle. Now looking at our sample problems, we're given circle P, we want to conclude that segment AB is congruent to segment CD. So based off our given, let's derive what information we have. We're given a circle, so I know that I probably should look for radii. Now in circle P, I have PA, PB, PC, and PD as radii. I know that all radii are congruent, so those segments would be congruent. Now I have two segments of one triangle congruent to two segments of another triangle. So I either need that third segment or I need an angle. Notice in my diagram, I have vertical angles. So I can say that angle APB and angle CPD are congruent. Now I can prove my triangle is congruent by side angle side. Once I have my triangles congruent, I can use CPCTC to show that AB is congruent to CD. So in my statement reason proof, I would have my first given of circle P. Then I derived my information of PA congruent to PB, congruent to PC, congruent to PD, because all radii of a circle are congruent. Then I had angle CPD is congruent to angle APB, because vertical angles are congruent. Now my triangles are congruent by side angle side of steps 2, 3, and 2. Now I can say that segment AB is congruent to segment CD because CPCTC. Notice also here in my side angle side reasons I have 2, 3, 2. If you want to get rid of that extra 2, you can just have 2 and 3. That is perfectly acceptable. Now looking at problem 2, I'm given circle O, angle T is comp to angle MOT, angle S is comp to angle POS. I want to prove side MO is congruent to side PO. If I notice, side MO is a part of this triangle and side PO is a part of this triangle. So if I can show that these two triangles are congruent, then I can use CPCTC to show that the sides are congruent. Notice I have circle O. Whenever I have a circle, that probably tells me that I'm going to use radii. So TO would be congruent to SO because those are radii and all radii of a circle are congruent. I also have vertical angles in my diagram. So angle MOT is congruent to angle POS because those are vertical angles. Notice if I have MOT and POS congruent, I have two angles that are comp to those two angles. So if angles are comp to congruent angles, then they are congruent. That would make angle T congruent to angle S, which would give me the triangles congruent by angle side angle. And then I could use CPCTC to show that MO is congruent to PO. So looking at this in my statement and reason proof, I'd first have my given of circle O. Then I can state that OT is congruent to OS because all radii of a circle are congruent. Now I need angle T is comp to angle MOT and angle S is comp to angle POS. Both of those are given. Now based off this information, I need angle MOT is congruent to angle POS because they're vertical angles and vertical angles are congruent. I can state that angle T is congruent to angle S because if two angles are comp to congruent angles, then they are congruent, or my congruent complements theorem. Now I can show that the triangles are congruent. So triangle MTO is congruent to triangle SPO by angle side angle. I use steps 5, 2, and 6. And then my last step would be side MO is congruent to side PO because of CPCTC. Now notice here where it says watch the correspondence. Remember, I have to match up each angle in each side with my congruent statement. If I was to say this was triangle MOT is congruent to triangle PSO, S does not match with O, so it would not be a congruent triangle. So whenever I have my statement and my proof for the congruency of the triangle, I need to match up each angle with each angle and each side with each side for the corresponding parts of each respective triangle. In this lesson we learned CPCTC stands for corresponding parts of congruent triangles are congruent. We will use CPCTC after we prove triangles congruent. All radii of a circle are congruent, the area of a circle is pi r squared, and the circumference of a circle is 2 pi r. That's a wrap on today's video. We'll see you in the next one.